Let's talk a little bit deeper about how we pass arguments into functions. In programming languages, there are really two ways that you can pass arguments into functions. One that we call pass by value, and another that we call pass by reference. When you pass an argument by value, the function basically receives a copy of that argument, and it only works with that copy. Any changes, any modifications that you do to the value that you're receiving is only applicable or only applied to that copy and does not impact or does not affect the original caller argument that you passed into the function. On the other hand, pass by reference basically means that you're passing in the address in which that variable is stored in memory, and any changes that you do, you're actually applying it directly to the original value, that you have in that memory. And if that variable is mutable, meaning that you can change it, then those changes are applied to the original value as well. Python arguments are always passed by reference, and this is great for performance because if I'm working with large data sets or working with large objects, I don't need to keep copying this data over and over again, consuming my computer's memory and computer resources just so I can copy them. In our case, we keep everything as is in memory, we pass the address of where that data is stored in memory to the function, and the function will then apply whatever changes it needs directly onto that original value. And if that original value is mutable, then it will apply the changes directly onto that variable. Otherwise, it will basically get a reference of what that value, and then if you're returning something out of the function, then you're just returning something out of the function. And let's see some examples of that. It'll make a lot more sense. Now, remember when we said that variables are really just labels that you're sticking on values? They're basically references that refer to some place in memory in which this value is actually stored. That is exactly what we're going to be talking about right now. We're showing you what that meant right now. So let's say I have a variable called x and it has the value of 7. Now, what I just said, that is actually inaccurate. The variable here does not contain 7 or does not contain the number 7. It contains a reference to a place in memory or to a container in memory in which the number 7 is stored. Now, how do I know where that place in memory is? We have one of those built-in functions that we have in the language called the id built-in function. And if I do id 7, that will basically return a reference to a place in memory in which that value is stored. Now, we cannot store multiple things in the same store in memory, which basically means that this number here is a unique number to this value that we're storing right now. Now, let's see what that looks like when we have function. Let's say I have a function here called cube that will receive some number, and it will return that number raised to the power of 3. Now, if I actually try to add a print statement here that will print out whatever the address of this argument is. So let's do a formatted string, cube or number is, and here's the number, and the ID or the address for it is, and here we have ID of number. Right, and let's save this function. If I call this cube method by passing in my variable x, now we already know the address of our variable x right here. If I call this function, here we get that the number 7 has the ID of 4382225, which is basically the same address that we saw earlier, meaning that when I pass this argument into this function, I'm basically passing it by reference. Both of these are referencing the same location in memory to access the value of this variable. Now, fortunately for us, most of the data types that we work with are immutable, meaning that you cannot modify them or you cannot change them. So let's see what I mean by that. So over here, let's say the first print is actually going to show us what the number is and what the ID for it. But if I come over here and change what that number is to, let's say, number 5, and let's add this print one more time over here before we do the calculation. If I execute this function or redefine what cube does and call this here, you notice here that when the number changed, the ID itself has changed, which means if I come over here and I try to print out, and let's copy this over here, let's print out what x used to be, or whatever the value that we passed into cube here. we'll see that the number and the address has not changed from the original value. So we maintain the fidelity of our data. We're not modifying it mistakenly somewhere in our code. And you'll understand the value of this as we dig deeper into the language and later on when we start talking about lists and tuples and the mutability properties of each of those.